In this video, our last video on regular expressions, we'll work two slightly more complicated examples to show some of the powerful things that we can do with our new tools. So as always, we begin by importing the RE module so that we have all the fun Python regular expression functions to play with. And now let's begin with our first example. So we're going to take some URLs and try to extract some of the most informative pieces of information from these URLs. So URLs have lots of components. I'm not going to go into a lot of detail on the different components, but here are a few that we care about. So one of them is the security scheme. So a couple of years ago, most sites had HTTP. These days, it's much more common to see HTTPS, which is much more secure. We can use regular expressions to grab the security scheme and figure out how secure a site is. We might want to know the host name. So the host name is what we often think of as the main part of the URL, like UCLA or Google. We might also grab the domain extension. The extension is .com or .edu or .org or .gov, for example. And finally, we might also want to get subdomains. So the subdomains tells you where on the site you are. Are you, for example, on google.com/images, doing an image search? Your subdomain answers questions like that. Additionally, many websites have this www prefix between the security scheme and the host name, but not all do, particularly ones that are hosted as subdomains of other domains. So let's go ahead and write a regular expression to extract these pieces of information from a URL. So there are lots of ways to do this, but let's go ahead and write a regular expression. So I'm going to take our list of websites today, and I'm going to bounce over to Pythex. So here is a string. We have some text that is not a website. Our websites today are, followed by 4 different websites that all have slightly different structures. And so we'd like to actually be able to parse all of these. So let's go ahead and create a regular expression. So first, let's try to grab the security scheme. So we know that the security scheme consists of HTTP, and then optionally followed by an S. So let's just say there can be 0 or more S's in there. Okay, and now let's take a look at our matches. I've gone ahead and thrown this into a group for convenience. So let's take a look at our matches. It looks like we matched the HTTPS for ucla.edu. CCLE is only on HTTP for some reason. So that doesn't have an S in it, but we've matched it correctly because we don't require that there be an S. It's optional using the star operator. And then we get HTTPS on the other 2 websites as well. Looks pretty good. Okay, next, colon / / are the next parts of our websites. We don't need to capture that in a group because we're not really interested in that. Okay, so now what I'd like to do is try to capture the www if it exists, and if it doesn't exist, then I'd like to capture the first part of the string here before the period. So there are a few ways to do this. I want to illustrate a way using a tool that we haven't introduced yet, but you saw it in the readings, which is the OR operator, so the Boolean OR operator. So let's give this a try. I'm going to create a new group, and in this group, I'm going to say, hey, either there's 1 or more copies of www, the string, or vertical pipe, or there is 1 or more other characters A through Z. Okay, so what does this do? This will match www if it exists. It will also match the CCLE in ccle.edu, and it'll match Phil Chodrow in philchodrow.github.io. Now, of course, we could actually do this without specifying the www entirely because it's all A to Z's anyway. But just to illustrate the use of this OR vertical pipe, I wanted to throw this in here. So we can do conditional matching. We can do Boolean matching where we actually have multiple conditions. Either we have the www or we have something else, and either way it goes into this group. Okay, next we know we're going to look at a period. So let's go ahead and capture a period there. Remember that we need to use this / operator to escape the period. Otherwise, we're going to use the period as a wildcard. Okay, we can have next, if we don't have a period there, so that's possible. So if we don't have a period there, I think we always have a period there. Let's actually skip that. Okay, so next, let's try to capture the next part of the statement here. So we are going to use another group. So this time I'd like to capture UCLA in ucla.edu. I'd like to capture UCLA in ccle.ucla.edu. I'd like to capture Google. I'd like to capture GitHub. I'd like to capture GitHub, not the IO yet. Okay, so how do we do this? Well, it's not too bad. We know we have one or more characters A through Z, and that is it. We get stopped because we then encounter a period. Let's account for the period as well. Okay, so now we are all set. Next thing I'd like to do is get the extension. So the extension is not too hard either. This is, again, one or more lowercase letters. And the extension might include a period as well. And we know there's at least two of those. So now I have github.io. Actually, this shouldn't include a period here. Yeah, so there we have github.io. We have ucla.edu, google.com, ucla.edu. Looks pretty good. Okay, so finally, let's get the subdomain. So the subdomain in this case is something like images on google.com or pic16a/schedule on the course schedule. So let's go ahead and get that. We know that we can encounter letters, characters A through Z. But we know before we encounter them, we also know that we can encounter one or more slashes here. So let's include slashes as well in our bracket expression. In pic16a, we see that we have numbers as well. So let's include numbers, 0 through 9. And finally, let's allow there to be any number of these items. Okay, so any number of slashes, letters A through Z, and numbers. Okay, so let's take a look at our matches. Sorry. So let's take a look at our matches. Looks pretty good, actually. So we see that we're matching HTTPS, we got the security protocol, we got the www in a separate spot, UCLA and EDU, we got the domain and the extension just fine. And we can check the other matches as well and observe that we are actually getting the behavior that we wanted. So this looks pretty good. So now we're ready to take our kind of monstrous regular expression here. This one's a little bit complicated, but all the tools are ones that you've seen before. Let's go ahead and use it in Python. So we'll do pattern equals raw string with this regular expression. And now I'm ready to do re.findAll, pattern, and s. And I can see that I've separated out all of the data that I want in the way that I was hoping to do. I have the security protocols, I have the domains, I have the extensions, all that good stuff. Okay, so one use of regular expressions, we can use them to parse URLs into their constituent pieces and learn things from those different components. Okay, let's do another example. So CSV files are really the best and most standard way for rectangular data files to be supplied to data scientists. And it should be a crime to supply rectangular data in any file format other than .csv. However, it's not a crime. And as a result, we often get data that's not nicely wrapped up in delimited files. It's actually kind of confusing how to extract useful data from it. So for example, suppose that someone gives us the following data set. So here I have 4 names and what looks like times that come after these names. Let's imagine that these are 4 runners and they are running a mile. And we've collected data on how quickly they run a mile and logged it in a string this way. So if I run the string, I see, okay, well, this doesn't look very good. I just have spaces separating out the names from their times. The spaces can be variable in number. So I have work to do here in order to actually extract the times associated with each name in a way that I can use in further computation. So let's go ahead and build a regular expression to do exactly that task. And we'll go right back over to Pyfex. Okay. So the first thing we need to do here is capture the names themselves. So let's make a group that represents the names. And we are going to capture, let's see, the names here can include uppercase letters as well as lowercase letters, at least one of them in each case. And okay, so that looks fine, actually. Okay. Next, we know that we can have any number of spaces. And we don't need to capture those. So we can represent spaces in a few ways, but the most nice way is with this /s space operator. And we can have any number of spaces in there. And actually, let's go ahead and just say we need at least one space. Okay. And now we're ready to go ahead and capture the digits. So lots of ways to capture digits. I want to use a slightly fancier tool than we've done before. So one perfectly good way to capture the digits would be using bracket expressions like this. A shorter way to write that you've seen in the readings is /d here. So we can use /d. Okay, so /d here represents the first digit. So the first part of the time here. Now let's go ahead and account for the possibility that there actually could be multiple digits here. So let's go ahead and say, hey, I'm going to allow multiple digits. Maybe they ran a 12-minute mile, and we'll capture that in a group. Okay. Next, I know that there's a colon separator. So let's go ahead and match the colon. Don't need to capture that in a group because I don't care about it. And then finally, let's have another group here for the seconds. So I have now minutes and seconds captured in different groups. So if we check our matches and our match captures over here, we see, okay, I have a name in group 1, I have the minutes in group 2, and the seconds in group 3. Going down to the bottom here, yeah, DD, name in group 1, minutes in group 2, seconds in group 3. Looks pretty good. Okay, so this one was a little bit simpler than the last one, and that's fine. So now let's go ahead and use this expression. So I will make a new pattern, and I'll make a new data set called parsed equals re.findAll, pattern and data. And now let's take a look at parsed. Yeah, this looks pretty good. I have tuples, first entry name, second entry minutes, third entry seconds, looks fine. Okay, so now the natural next thing to do would be to compute the total time in units of seconds for each of these runners. So we can do that in the following way. I'll use a dictionary comprehension, similar to a list comprehension if you haven't seen it before. So for each of these tuples, I'll say, let's see, for p in parsed, so this is a comprehension statement here. I'm going to take each tuple in parsed here, call them p, and I'm going to take the first item and have it correspond to 60 times the integer version of p1 plus the integer version of p2. I'm using these integer conversions because these are strings after they come from regex, so I need to convert them into numbers. And if I do this, I see I now have a dictionary in which each person is associated to the time in seconds it took them to run this mile. So regular expressions have allowed me to take this kind of annoying unstructured data set and convert it into a nice structured dictionary that I can then easily perform subsequent computation on. Okay, so thanks for watching our series on regex, regular expressions, and we will move on to numerical computation in the next videos.